Section 5.5 is standard form. I can graph linear equation using intercepts, and I can write linear equations in standard form. Big ideas here. The standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. Standard form here is going to have all of our variables on one side in alphabetical order equal to a constant. The standard form of a linear equation makes it possible to find intercepts and draw graphs quickly. So again, here on page 322 is our take note for standard form. Standard form of linear equation is ax plus by equals c. Again, a, b, and c are real numbers, and a and b are not both 0. So here we're going to find x and y intercepts. So intercepts happen where our graph crosses the axis. So for example, if I have this line, my y-intercept, we know, is where it crosses the y-axis. Where it crosses the x-axis, though, is my x-intercept. And some cool things about these points are that for a y-intercept, my x value is always going to be 0. It always goes through this line where my x is 0. For an x-intercept, my y value is always going to be 0. It's where it crosses our x-axis, and there we haven't gone up or down at all, so our y value is 0. And we can use that idea here to find x and y intercepts. So again, to find an x-intercept, we plug a 0 in for y. So I have 3x plus 4 times 0 equals 24. And then I solve for x. Multiply first. We want to simplify both sides. Add. And now we can solve. X is being multiplied by 3, so we divide by 3. And this gives me an x, and I want to label it as an intercept because it's a point. It's my x-intercept at 8. If we write that as an ordered pair, x is 8 when y is 0. To find a y-intercept then, I'm going to plug a 0 in for x. So again, I have the same formula here, but instead of an x, I replace it with a 0. I'm going to go ahead and simplify. And we can solve. Y is being multiplied by 4, so I divide by 4. And I get y, again I'm going to label it an intercept, equals 6. And if we want to here, we can write that as an ordered pair. X is 0, y is 6. So either way there. Now feel free to pause here. What are the x and y intercepts of each equation? So here I want to know what is my x-intercept and what is my y-intercept. I find an x-intercept. It's where it crosses my x-axis, which means my y value is 0. And to find a y-intercept, that's where it crosses my x-axis. So my y-axis where my x value is 0. So an x-intercept is where it crosses the x-axis, which means I'm not up or down at all. My y value is 0. My y-intercept is where it crosses my y-axis, and there I haven't gone left to right at all, so my x value is 0. Now we can plug those in and solve. So 5x minus 6 times y, which we said is 0, equals 60. So again, I just replaced y with 0 here. Same thing for my y-intercept. I have 5x, which we said is 0, minus 6y equals 60. I can simplify here by multiplying first, and then by subtracting. Same idea here, I multiply first, and then I subtract. And now I can finally solve. Being multiplied, so I divide. My x-intercept then, and I want to label it as an intercept, is at 12. My y-intercept then is at negative 10. And we can write those as ordered pairs. Here, x is 12, y is 0. Here, x is 0, y is negative 10. So, if you notice here, our process is the same to find an x and a y. The only difference is where we plug in a 0. So to find an x-intercept, my y value is 0, I plug in a 0 for y. To find a y-intercept, I plug a 0 in for x and solve for y. And in B, here, again, I'm trying to find my intercepts. So, to find an x-intercept and a y-intercept is our goal. So, to find an x-intercept, where I cross the x-axis, it means that my y value is 0. And to find a y-intercept, it's where I cross my y-axis, it means my x value is 0. So I plug those values into my functions. Here we said y is actually 0 at my intercept. And here we said x is 0 to make a y-intercept. Before we can solve, we want to make sure both sides are as simple as we can get them. And the same thing over here. Before we can solve for y, we want to make sure both sides are as simple as we can get them. Both expressions are simplified. Now, x is being multiplied by 3, so we go ahead and divide. We change one side, we change both. I get an x-intercept at 4. Y is being multiplied by 8. So my y-intercept is going to be at 12 over 8, which I can reduce to be 3 over 2, or 1.5. Again, we can write those as ordered pairs if we'd like. Here, x is 4, y is 0. Here, x is 0, y is 3/2. In example 2, we're graphing a line using intercepts. We want to know what is the graph of x minus 2y equals negative 2. Here it's in standard form. X and y are on the same side. So using intercepts a lot of times is going to be helpful here. So I'm going to find an x-intercept, and I'm going to find my y-intercept. So to find an x-intercept again, I plug a 0 in for y, because where I cross my x-axis, my y value is 0. And to find my y-intercept, where I cross my y-axis here, my x value is 0. So in my equation, I have x minus 2y. But here we said y is 0 equals negative 2. And for my y-intercept, we have x, which we said was 0, minus 2y equals negative 2. We want to simplify if we can. So multiply, subtract, and here I get x equals -2, which means that my x-intercept is at -2. So on my x-axis at -2, I have a point. I can do the same thing for simplifying for my y-intercept here. All the way simplified. Y is being multiplied by -2, so I'm going to go ahead and divide. And my y-intercept then is going to be at 1. So where I cross the y-axis at 1, I have a point. And y-intercepts we've dealt with before in terms of slope-intercept form. Then we want to use a straight edge, connect our dots through our points, extend that line. It's not a terrible idea to try and extend your slope. So between these points I went up 1 over 2. So up 1 over 2 again, up 1 over 2, up 1 over 2. It just makes sure that our line is a little bit more accurate, because if we only have 2 points, it's kind of easy to get just a little bit off. You know, we can still hit those 2 points, but maybe not right in the middle. So if we can extend that slope, it makes it a little bit more accurate. So again, we're going to graph here, and it's in standard form. So when we have an equation in standard form, we are going to use intercepts to graph most often. So to find an x-intercept and a y-intercept. To find an x-intercept, we plug a 0 in for y. To find a y-intercept, we plug a 0 in for x. So my equations here, 2x plus 5 times y, which here we set is 0, equals 20. And then we have 2x we set is 0, plus 5y equals 20. Go ahead and simplify. X is being multiplied by 2, so we go ahead and divide. And I get an x-intercept of 10. Y is being multiplied, so we go ahead and divide. And I get a y-intercept of 4. So on my x-axis at 10, I have a point. And on my y-axis at 4, I have a point. Then we can connect these with a straight edge. And an arrow to show that they continue. And there's our graph in standard form. Here we're going to graph x equals 3. So x equals 3 on my intercept. X also equals 3 at the point 3, 3, at the point 3, 6, at the point 3, -3. All of those points have an x value of 3. All of those points make this true, which means we can connect the dots there, and we have a vertical line through 3. Mine's off just a little bit there, but you get the idea. Same idea here for y. Y equals 3 at my y-intercept. It also equals 3 at the point 3, 3, and at 6, 3, and at -3, 3. All of those have a y value of 3. It makes it true. So here we have a horizontal line through y equals 3. Again, arrows to show it continues. And there we go. If it's just x equals a number, it's a vertical line through that intercept. If it's y equals a number, it's a horizontal line through that intercept. And I will continue on in another video.